All right, welcome back. So now I'm going to show you how to program in an Arduino IDE. So an IDE is an integrated development environment. So basically all that means is you're writing code here and it's going to be uploaded to the Arduino board. And then that can talk to all your other components to tell them what to do. And Arduino is great because they have examples that you can uh, just reference to write your own code. So don't feel overwhelmed. If you don't know how to program, I am not great at programming. I've never been that great at it, but I use these examples as reference to figure out how to write my own code, and it makes it super simple. So I'll show you how to do that. So as soon as you have the Arduino IDE open, it's going to come up with this like blank file. So what we want to do is go to File, and then you go to you go File, Examples, and then for our file that we're going to just reference for this example, we'll go to Basics. If you scroll all the way to the top, I'm pretty sure you guys should have these these examples. Yeah, they say built-in examples. Let me know if you don't. But this should be here for you when you load up the Arduino IDE, and then we're going to open Blink. Okay, so let's talk. I'm going to just break down each line. Sorry if you already know this information, you can just skip past it, but I want to make sure you guys really understand what's going on here. So, this is an example for basically how to turn an LED on and off, on and off. Okay, so let's start with the basics. So, all of these lines up here, anything that you see that's like grayed out and has these two like forward slashes next to it, that's a comment. That's basically communicating to you that like they're basically notes, right? They're trying to communicate to you certain things about the program or how it works or like certain things you should consider. Whoever wrote this program is trying to tell you what's going on, basically. So all of this that I have highlighted here doesn't influence how the code runs at all. It's just like notes telling you what's going on, right? Okay, so the first thing that we have going on right here is this line that says int LED equals 13. So, what's going on? So, int is this like light is in this light blue text. It's recognized by the compiler, and it's basically saying we're creating a new variable for our program, or that's what they did here. So they're creating a new variable called LED, and they're saying that equals 13. What does int mean? Int stands for integer. So int is any number that's like a whole number. So 1, 2, 3, 4, 5, 6, 7, 8. Those are all integers, right? So int LED equals 13. So int is like you're basically telling the software or the IDE, the compiler, like what type of data are you pulling in? Like there's different data for like is it a word? If it's a word, that's like a string. Is it um a long number, say you're dealing with like pi to like the 6th decimal point? That's a different type of digit because that's not an integer, right? It's got decimal points. They're all different types of data types, basically, that you can tell the program what type of data you're dealing with. But for now, we're just going to deal with integer, and that's what this is. So that's all that int means. It just means you're defining what your variable is. It's an integer. What numbers are you going to be dealing with? So LED is just a name. You could name this anything you want. Right now, they named it LED because what this is communicating to us or to the Arduino is what port the LED is talking to, right? So on their specific example, they were talking to port 13, which I think is communicating to, there's like a LED on board. There's an LED on the Arduino that you can write software to. For this specific example, we plugged in our LED to port 8, so we're going to change 13 to 8. So int LED equals 8, right? So we've defined the variable LED that we could name whatever we want, right? This could be whatever we want as an integer. That's what int means, right? And then we're saying equals, so we're setting a value to LED before the program even starts, right? We're saying this variable equals 8, and then you have to end the line with a semicolon. That's basically telling the IDE that this line of code is over and to start looking for the next piece of code, right? So from here, there's sort of like two different like sections of code that you can program. So there's void setup and void loop that basically come by default in every new file that you create with Arduino. The difference is void setup means that you put anything in void setup that you want to run exactly once. As soon as you give the Arduino power, it's going to boot up and run all this code that it sees in setup exactly once. And then void loop, for void loop, everything is going to run an infinite amount of time. So instead of running once, it's just going to, whatever the first line of code is, it's going to read that line and run through all of it. And then once this finishes, it's going to jump back to the beginning and keep running this infinitely forever, right? So let's go through this. What is void setup? What do we have going on in void setup? So in void setup, you see pin mode LED, comma, output, semicolon. So basically what we're doing here, pin mode is a like function or piece of code that the Arduino understands, and basically you're trying to tell the Arduino is whatever we're plugging in an input or an output. So like a good example for an input would be like you have a sensor, right? And it's taking in information. Think of the Arduino as the brain of whatever you're programming, right? Like your eyes are the input or are sensors, right? You're taking in information from the environment, and then your brain or your Arduino is then processing that information and telling you what to do, right? So then let's say for example, I see an approaching car. My brain recognizes that the car is approaching and then tells my legs to move out of the way. So the input would be my eyes taking in that information. The output would be, my brain telling my legs to move out of the way. So same thing here, right? We're telling the Arduino basically what's going on. The LED is an output. We're sending information out to the LED and telling the LED what to do. The LED isn't taking in information to us. So basically we have to communicate that information to the Arduino, and that's all that's happening here. So pin mode basically establishes this line of code, and then you do an open parentheses, and usually with like these types of functions, they take a certain amount of arguments or parameters that are separated by commas. So pin mode specifically here is taking 2 arguments or parameters. The first one is basically what port you're talking to. So we're saying pin mode is occurring on whatever port was on this variable. So we've defined this variable up here to be 8. So we're saying pin mode on port 8, comma. And then in all caps, we're telling the Arduino what type of what's going on is an input or output. We said it's an output, and then you end it with close parentheses, and then a semicolon. So the reason why we do that is you could have typed like 8 here, which is the port that we're communicating to, but it's useful to define a variable as whatever port you're talking about. Because let's say we didn't do this and we have a bunch of different lines here. Let's say we have another 100 lines all throughout our code that are referencing port 8, and for whatever reason, maybe we want to change port 8 to 9. Okay, how do we fix that? Now we have to change every 8 to a 9 in our code. Instead of, if we did it this way, where we say LED goes here instead of just the number 8, now all we have to do is go up here at the top and change LED, what LED equals to. Now we can just change this to a 9, and then boom, it would all update because now this is all referencing a variable that is defined up here. But we're not doing that, and our port number is 8, right? Okay, so that's all we have for the void setup. We've defined a variable called LED, setting it equal to 8. We end that line. Then we go to void setup. Everything that runs exactly once. We're telling the Arduino there's an LED on port LED, or the variable 8, or the variable LED that we've defined to be 8, and we're telling it that it's an output. So now we go down here. So void loop, this is everything that's going to run basically forever. And all that's going on here is we're telling the Arduino to turn on an LED for 1 second and then turn off the LED for 1 second. And then it's jumping back to the beginning and it turns it on again for 1 second, then turns it off for 1 second, and it keeps going in a loop forever. Okay, so let's break down each line. So you see this orange text? That's like a function that the Arduino recognizes, um, and is commonly used in the Arduino IDE. So how do we tell the LED to turn on? We have to tell the Arduino, okay, are we reading from like a component, or are we writing to it? So once again, the LED is an output. We have to write to it to turn it on. So digital write takes two arguments, just like pin mode. You have to tell um, the Arduino which port you're trying to communicate to. Just like before, we've made it easy by defining a variable for the port, which is 8. So we just type in LED here for the first parameter. And then the second parameter in all caps is high. So what's going on here? They actually tell you in a comment. Turn the LED on. High is the voltage level. So basically, you're giving that port a high voltage, which basically completes the circuit and turns that LED on, right? That's all that's happening here. You're saying digital write, which means write or give a signal out from the Arduino's brain to the LED on port 8. And then you're saying give it a high voltage, which means it gives it power to turn the LED on. And then you end that with the semicolon. The next line is a delay. So delays are super useful. Basically, it's like take a break or like do the last thing for a set amount of time. You're like setting how long things occur. So this basically will stop the program and say, do whatever you were just doing for a set amount of time. So this is in milliseconds. So 1 full second is 1,000 milliseconds. So all it's saying is, okay, do whatever you just did for 1 whole second. That's what this is saying, right? And then you have, then you have a space, then you have a little break here, and then what happens next? So it's a digital write again. We're communicating to, it's exactly the opposite, right? A digital write, we're communicating to the port LED, which we defined to be 8 up here, comma, and then now we're going to send it a low voltage. So it was just given a bunch of power. Now we're taking the voltage away, and now the LED is going to turn off because it doesn't have power to complete the circuit. That's all that's going on here. So digital write, we're telling the LED, give it a low signal, and now it's turning off. How long do we keep the LED off for? Delay of 1,000 milliseconds. Right? So then this is the last line of the code. So what happens now? The LED turned on for 1 second, right? That's what this is. And then we said turn it off for 1 second. So it's on, 1 Mississippi. It's off, 1 Mississippi. Now it happens. Oh, we're out of code, but this is a void loop. So it goes from here back to the beginning, and it's going to loop infinitely forever. So it was just off for 1 second. Now it says turn it on, 1 second. Turn it off, 1 second. It's over again, jumps back, and it keeps looping forever, right? So that's a little bit about all the lines and like sections of the Arduino IDE. Now I'm going to show you a bit about like how to actually upload your code. So there's a couple of different options up here. You guys can look around if you want. There's some preferences that you can change around. If you want to change how the IDE looks, you just go to File, Preferences, right? You can change like font size or whatever. I don't really mess with any of that. What is really important is basically you're gonna get a blue USB cable, and basically you plug the blue USB into your computer, and then you plug the other end into your Arduino board. And basically what's gonna happen is you should have, if you go to Tools and then Port, for me it always says COM1. This isn't the USB port you're trying to communicate to. Another one should pop up. So for example, I'll plug in mine and I'll show you. All right, so I just plugged in my Arduino. I go to port. Okay, so now it says, look here, it says COM9 Arduino Uno. And then also the other thing you have to make sure of is you go to board. You shouldn't have this thing that says Teensy Duino. That's like add-on that I did for another project. It should just be like Arduino AVR boards. You basically have to tell the IDE which type of board you have so it can like properly compile all the code. And then you go to Arduino Uno. That's the board I'm using. If you're using a different board, you'll have to upload it to that board. Other common boards I've used is the Arduino Nano or the Arduino Mega. I haven't really messed with any of these other boards. Basically, just make sure that you're uploading to the correct board. Whatever board you have, you pick the correct one here, right? And that's basically it. And then I just click this button, upload. What these buttons are is verify, basically runs through your code and make sure there are no errors. Like if you forgot like a semicolon here and you press verify, look, it tells you, it like highlights the line. It gives you a little information about maybe what you're missing. It says expected semicolon before this token. So you kind of just have to do some investigating and make sure you have all your semicolons, your commas in order. And you'll understand like where that sort of thing goes just like through uploading scripts throughout your projects. But I rarely press this button. Usually I just go straight to upload because when you press upload, it will automatically verify and compile it for you. So upload is like verify and then like take the script and actually put it on your board. So I'll do that right now. Should take a second. It'll say compiling sketch. And then at the end, it'll say done uploading. It'll also give you some information about like how much storage you've used on the board and like how much RAM you have or whatever. If for whatever reason your script isn't uploading, once you press upload, there's a few things that I do. I first make sure you've got the correct board. That's the first thing selected here. So make sure mine is Arduino Uno. Make sure whatever you're using matches in this option. The other thing is to make sure, obviously, that also you have the correct port selected. If it's still not working, you can either unplug the USB or unplug the cable from the Arduino side and just like plug it out or take it out and plug it back in. There's also a red button on your board you should see that's like a reset button. So I'll do that and unplug it and plug it back in a couple times. If it's still not working, I'll restart my computer, but some combination of all of those will usually fix the issue. All right, pretty simple, but as you can see, we've told the Arduino, talk to pin 8, send a signal out to the LED, turn the LED on 1 second, turn it off for a second, and then it's running through the cycle of the void loop and doing this over and over again. I'll see you in the next video where we're going to work on the servo motor.